Good afternoon. Can anyone have rights to admit students? Am I audible?
Yes, ma'am.
Yes. Is it possible that a student can admit the other students? Can anyone see where the rights are? Because I have to conduct the lecture today from Mumbai. No electricity in college. Okay. I will share the screen and will discuss one point only today regarding the comparator. Can you see the screen?
Yes.
Yes. Okay, there is one point that is magnitude comparator or it is called as a digital comparator. As it indicates that it means it is going to compare the two bits. Okay, so basically it is a combinational circuit designed to compare the two n-bit binary words applied at its inputs. The comparator has the three outputs, namely, what are the outputs? Because we are comparing the things. Suppose I have to compare the number 4 and 5. How we are going to compare? What I can say, what is the relation between 4 and 5? It can be less than, it can be greater than, or it can be equal to. Isn't it?
Yes, ma'am.
1 minute. It is quite difficult. Okay. So if you are going to compare any number, how you are going to compare? It can be a greater than, it can be less than, or it can be equal to. Isn't it? Means comparator has always these three outputs. Okay. So for n bit, there can be number of bits. It's see there. This is the word A. We are applying as input. Word B as another input that you have to compare. So it consists of n-bit digital comparators, and finally we are getting the output like A less than B, equal to B, or A greater than B. Greater than B. Before turning towards the 2-bit comparator, we'll go for the single-bit comparator. Okay. See, we'll see first 1-bit binary comparator. Can you see the? Means what? You have to compare the bit. You have to compare between A and B. So as we are saying, this is a 1-bit binary comparator. So this is the truth table of a 1-bit comparator. What it is? That A can be 0, 0, 1, 1, B can be 0, 1, 0, 1. That is a 0, 0, 0, 1, 1, 0, and 1, 1. And what are the outputs? That y1 can be a less than b, y2 is equal to a equal to b, and y3 is equal to a greater than b. Now see, a is 0 and b is 0. What it means? What is the relation between a and b here?
Equal.
Yes, it is a equal. So see, up till now we have studied lot of things, and in many things what we are doing, we are finding out truth table, we are drawing the K-map, and we are finding out the equation from the K-map. And again from that equation, we are building the logic diagram. We are drawing the logic diagram. Okay, that means we are building the hardware for this to realize the things. Now see, A is 0 and B is 0 means Y2 is going to be high. So our in truth table we can write Y2 is equal to 1 only. So other two terms are 0, 0. Okay. Next 0, 1. A is 0 and B is 1 means what?
A is less than B.
A is less than B. So which column is going to be high? Or
Y1.
which output will be 1? Yes, Y1. So Y1 is a 1 and other are a 0. Similarly, 1, 0. 1, 0. See, that means A is 1 and B is 0. So A is greater than B. Means which column is going to be 1 now?
Y3.
A is greater. Yes, Y3 is 1. And for others, you can write 0, 0. So 1, 1. Finally, 1, 1. Again, it is equal to condition. A is equal to B. So Y2 is going to be high. So we are writing 1 in the Y2 column and others we are writing it to 0. Is there any difficulty while writing this truth table for the 1-bit comparator?
No, ma'am.
सभी को समझ में आया क्योंकि 1 बिट अगर पहले समझ में आया तो 2 बिट में कोई भी प्रॉब्लम नहीं आएगा. अभी क्या करो आप लोग, you just form the K map for these three conditions, that is a y1 is equal to a less than b, y2 is equal to a equal to b, and y3 is equal to a greater than b, and find out the equation from that, and then we will discuss about the logic diagram. Okay, can you, are you able to draw the K map from the truth table, each and every student? कर सकते हो? See here, already K-map is shown here, just you have to understand the things and write down on your own. Here A is on side, B is on another side. See, what I am asking, is there any difficulty? Can all of you draw the K-map from the truth table? Yes or no? Yes or no? Or should I explain the K-map also? Should I?
Yes, ma'am.
What? You can draw the K-map or should I explain?
Ma'am, explain.
Explain. Okay. I hope there is no difficulty in the truth table. Okay. Second, we are drawing the K-map for suppose y1 is equal to a less than b. So just let it be. Y1 is equal to a less than b. Okay. So a and b are two inputs we are writing on a K-map on both sides. So b can be 0 or 1. So this is a b bar b written like this. Here also a can be 0 or 1. So a bar. Write down the condition where y1 is equal to a less than b. कब है वो 1? y1 is equal to a less than b. For which condition it is a 1? Second year से मैं मैडम करेंगे बंद कर लाइट आ गई ओ बी से करूँगा ना. For which condition? y1 is equal to a less than b.
A0 B1.
A0 b1, yes. So where is your A0? See, first line, first horizontal line. So 0 and b is the 1. So for that column only you have to write 1. Otherwise it is a 0. If you see this y1 is equal to a less than b, आप लोगों ने अगर y1 का कॉलम देखा तो बाकी की जगह क्या है 0 0 0 और सिर्फ y is when it is 1 when a is equal to 0 and b is equal to 1 accordingly write that one. So circle अब यहाँ पे कुछ बन रहा है क्या पेयर कॉर्ड बन सकते हैं पेयर कॉर्ड बन सकते हैं
No, ma'am.
तो क्या हो रहा है वहां पे सिर्फ सिंगल वन है so you write them directly equation. So what will be the equation then? y1 is equal to
B.
can it be b only? There is no reduction any. See vertical line as well as the horizontal line. Vertical column for vertical column it is a b and for horizontal it is a a bar. So y1 is equal to a bar b. आप लोग के में भूल गए क्या y1 is equal to a bar b. ये समझ में आया Similarly go for the second that is a equal to b. अभी बोलो मुझे कब 1 है ये a equal to b 1 कब है
AB00 AB11.
Yes, for 0 0 and for 1 1 it is a 1. So write down only in that part only 0 0 1 1. Write down 1 there. Okay. And other places you can write the 0 0. So just write down it and again write down the equation for that. See, here also is there any pair is going to form? Diagonal elements, diagonal pair is allowed in K-map? What is the rule?
No, ma'am. Diagonal is not allowed. Corners allowed.
Whether the pair quads are allowed, but here is there any quad?
No, ma'am.
Quad is forming? No, pair is also not forming. So again you have to write down the individual equation. While writing the individual equation, it is not quite difficult. See the horizontal line, see the vertical. What is there? What is the input? So here it is a bar, and for the first one it is a bar, and B is the also I think B bar. So it is a bar B bar, and for another one, what is the equation? That is the A and B. बराबर है? So finally y2 is equal to a bar b bar plus ab. बराबर इक्वेशन समझ में आया?
Yes, ma'am.
And then for y3 is equal to a greater than b. कब 1 है ये a greater than b? See the column from the truth table. We are following the
A1
K-map from
B0.
the truth table only. Yes, A1, B0. So now see the columns or rows. So A1, B0. Write that 1 in that part only. Otherwise it is a 0. In that block you have to write down 1 only. Otherwise it is a 0. So what will be the equation now? Y3 is equal to
AB bar.
yes, because A is a 1 and B is a 0. So B bar will be there. So Y3 is equal to AB bar. Now tell me, what will be the logic diagram? For first, which gate is required? Y1 is equal to A bar B. कौन सा गेट लगेगा हमको?
One not gate and one AND gate.
Yes. For second, for second equation, सिंपल के बाद हम डिफिकल्ट के लिए मूव होंगे। अगर ये आपको समझ में आ रहा है तो आप लोगों को सिर्फ 2-bit कंपैरेटर ही है। ENTC students are having 4-bit comparator also. सेकेंड इक्वेशन क्या चाहिए? अगर डिजिटल आपको समझ में आ रहा है तो यू शुड इजीली एबल टू टेल मी द थिंग्स। Y3 क्या है?
OR gate, NOT gate, and AND gate.
हाउ मेनी AND gates are required?
2,
Yes. And OR gate?
1.
Good, very good. And for the third equation? Third is the Y3 is equal to AB bar.
1 NOT, 1 AND.
Yes. Now see the logic diagram. Okay. See here, you can see easily whatever we have seen now using basic gates. And here again, this is realized and XNOR gate. It is not that much. It is not required. You can draw it using the basic gates only. So whatever we have discussed, see there. For first equation, y1 is equal to a less than b. It is equal to a bar b. So only one AND gate is required and one inverter is required, so that you should get the a bar. Similarly, for the another equation, this is the a bar b bar into a bar b bar plus ab. Yes. So what is that? You can directly draw the XNOR also. See the below diagram. Okay. Because it is nothing but the XNOR equation. By using basic gates, you can use the AND or you can directly draw the XNOR gate. And the third one also, you have to draw the AND gate. All of you got this? सभी को ये समझ में आया? See, just first you draw the truth table, draw the K map, then I will show that page only. बुक निकालो, वहां पे ड्रॉ करो ये सब कुछ, राइट डाउन दैट इक्वेशन एंड देन ट्राई टू ड्रॉ द लॉजिक डायग्राम. डू इट, देन वी विल गो फॉर द 2-bit कंपैरेटर. ये अगर समझ में आया तो 2-bit इजीली समझ में आएगा, लेकिन क्योंकि उसका ट्रुथ टेबल फिर बड़ा है, अगर ये ही समझ में नहीं आया तो उसमें भी प्रॉब्लम आ जाएगा आप लोगों को. आर यू गेटिंग मी? किसी को समझ में नहीं आ रहा है जो बाद में ज्वाइन हुए? किसी को लगता है क्या रिपीट करना चाहिए फिर से? अरे आप लोग बोलो, नहीं तो मुझे लग जाएगा कि डिस्कनेक्ट हो गई मैं. विपुल राउत, के मैप समझ ली का?
Yes, ma'am.
कावन तुम्हें के मैप का नहीं आता भी?
मैम के मैप वाला कॉन्सेप्ट के टाइम था नहीं था मैम, फिर बाद में नोट से पढ़े, इसलिए उतने अच्छे से नहीं आते.
ठीक है, अभी समझ में आया ना कैसे करते हैं?
Yes, ma'am.
नाउ ड्रॉ इट, ट्राई इट.
Yes, ma'am.
सभी को ड्रॉ करना है, सभी को लॉजिक डायग्राम ड्रॉ करनी है. देन ओनली वी आर गोइंग टुवर्ड्स द 2-bit कंपैरेटर एंड जस्ट आई हैव टू फिनिश द कंपैरेटर टुडे ओनली. See, for computer students, mock exam, there will be mock exam from university side. I don't know. For third and final year, we are conducting again online exam, university online exam, in same exam in college level. But from For you, I don't know, because till DSC, direct second year admissions are not there. But if there is again instant exam at college level, I will keep the units as per your syllabus, that is a 1-2. So there will be all these contents, that comparator marks. Last time it was not there, but for this exam it will be there. Okay, comparator marks, D marks, all these things, parity generator, parity checker, and what that look at, carry generator, all these things will be there for exam for the computer students only. Okay, and for ENTC students the same syllabus will be as previous. समझ में आया मैंने अभी क्या बोला? अगर हो गए तो बोलो, सेकंड ले लेते हैं.
मैम completed.
With logic diagram or without? Now draw the logic diagram for this. आप लोगों के पास अभी इक्वेशन है, तो इक्वेशन देख के आप लोग खुद से ड्रॉ करो. कितने स्टूडेंट्स हैं? 50. आप लोग सिर्फ देख के ड्रॉ मत करो. आप लोग अगर आपको कंसेप्चुअली समझ में आया है तो आपके पास इक्वेशन है, जस्ट यू शुड ड्रॉ ऑन योर ओन एंड देन वेरीफाई. मैं डिस्कनेक्ट हो गई. आई विल शेयर स्क्रीन अगेन. Okay, should I go to a 2-bit comparator? We'll discuss it. You just try it on your own as like a homework, and we'll discuss in a next lecture. Okay. Start करें 2-bit comparator.
Yes ma'am.
See, for 2-bit comparator, what do we need? We need a 2-bit. So we are using that here. If you see the truth table, it is a A0 A1 and B0 B1. बच्चे कब तक ज्वाइन होते हैं? Okay, so what are the inputs now? Now it is a 2-bit comparator, so don't confuse. We are saying that 2-bit means we need a 2-bit. So we are considering as a A0 A1, that is a 2-bit, and again we have to compare with the another one. So we need another number also of 2 bits. So B0 B1 is another number. So A0 A1 and B0 B1. Similarly, what will be the outputs here again? Are they going to be 6 here? For comparator, For 1-bit comparator, there was 3 outputs. What do you feel that how many outputs will be there for 2-bit comparator? Whether it is changing or not?
नो मैम, बी नॉट 1 और बी नॉट 0 को बी ही माना गया है, बस एक ही वैल्यू।
Yes, only inputs are increasing. It doesn't matter how many inputs are there. There will be only 3 outputs. That means for comparison, we need only 3 conditions. That is a less than b, a equal to b, or a greater than b. Here maybe a not a1, a2, a3 for n bit up to n, and b not b1, b2, b3 up to bn. Even though there will be 3 outputs. Okay, so a less than b, a equal to b, and a greater than b. Now see, for a not a1 as a 0 0, b not b1 is a 0 0. So which one will be go high, or which output will be gone here?
ए इक्वल टू बी।
Yes. Second for 0 0 0 1.
ए स्मॉलर देन बी।
A less than B, yes. For 0 0 1 0, because now it is a 0 0 and it is 1 0. Means again
ए स्मॉलर देन बी।
A less than B, yes. Similarly for 0 0 1 1, it is the A again A less than B. Go for the another condition and just write down the truth table for each one. Okay, can you?
यस मैम।
Just prepare the truth table first and then we will discuss or we will go for the K-map. All of you draw the truth table. अगर किसी को K-map समझ में भी नहीं आ रही है, at least you should able to draw the truth table if you understood the things. आपको अगर समझ में आ गया है कंपैरेटर का कंसेप्ट, तो at least you should able to draw the truth table. डीमक्स और पैरेटिव चेकर के लिए हमें और एक लेक्चर लगेगा. Then we'll finish complete the third unit also. ट्रुथ टेबल में किसी को कोई डिफिकल्टी है? किसी नंबर पे ए नंबर पे गलत है? Can there be printing mistake?
मैम 0 1 1 1 कंडीशन में हम किसको ग्रेटर लेंगे, ए को या बी को?
0 1 1
हाँ
देखो, A1 A0 अलग है और B1 B0 वो अलग है. So A1 A0 is a 0 1, yes, and B1 B0 is a 1 1. बराबर है?
यस मैम.
So 0 1 there are only 1 1, and here it is a 1 1. Both are 1 1. So which one will be less and which one will be greater? समझ में आया?
नो मैम फिर से रिपीट करिए.
0 1 और 1 1.
यस मैम.
तो 0 1 ऊपर का समझ में आया क्या आपको? फिर 0 1 1 0.
हाँ यस मैम समझ गए.
तो ये तो 1 और 2 जैसे हो गया. So it represent 2.
1 और
So
5
which
की
one
वैल्यू
is
हो गई मैम.
greater?
मैम 1 1
less
0 वैल्यू
than.
5 की है. यस मैम.
और नीचे का 0 1 1 1. So 0 1 you can say like 1 in a decimal, and 1 1 you can say now like a 3. It will be 3. So which one is the less?
0 1.
Yes, that's why A less than B is a 1. कंपेयर करते वक्त हमें पहले यूनिट प्लेस देखना है, फिर जैसे डेसिमल में करते हैं वैसे ही, फिर नेक्स्ट क्या बोलते हैं 10th प्लेस लाइक दिस. यहाँ पे 2:0 का प्लेस चेक करेंगे, फिर 2:1 का, फिर 2:2 का. गॉट इट?
यस मैम.
Even though it is a 2-bit comparator, all of you just you have to compare bit by bit only. Go bit by bit. Code for today's lecture is 3 4. Okay. Can you try it at home for KMAP?
यस मैम.
Yes. Any other reply? आप लोग घर पे एज होमवर्क करोगे क्या केमैप? अगर कुछ प्रॉब्लम आ रहा है तो नेक्स्ट लेक्चर में हम लोग फिर से डिस्कस करेंगे. नो इश्यू. ओके, बिकॉज इट इज अ टाइम कंज्यूमिंग एंड यू नीड अ टाइम. जस्ट आप अपना खुद का टाइम ले लो. 3 ही इक्वेशन के लिए फॉर्म करना है आपको केमैप, लेकिन आराम से करो. कंफ्यूज हो रहा है तो लीव इट. विपुल क्या अभी
Yes,
थोड़ा
ma'am.
बड़ा के बड़ा केमैप रहेगा. आप एक बार रूल देखो. ट्राई टू ड्रॉ इट. शुड आई शेयर दिस स्कैन कॉपी?
Yes, ma'am.
Okay, I'll share it on a group. Okay. Then try it as a homework. Should I end the meeting then?
Yes, ma'am.
Okay.